We're going to solve for all the angles and side lengths of this triangle in a grid. And the nice thing about this, having a grid here, is that we can make right triangles by using the grid lines. So I'm going to do it like this. So I've got my right triangle here, and we're going to do this slightly differently. We can try to find the interior angles directly, but that would be quite complicated. So we're going to simplify this, and we're just going to find the outside angles using this right triangle, because we don't have right triangles in here. Now that said, we could always make the right triangles on the inside, but it's going to look a little bit cleaner if we do it on the outside, because they're the same triangles. So the first thing is I want to find out the angles in this right triangle. So there's my 90-degree angle. If I count, this is a 6 by 6, so this is a 45-degree triangle, so I know that those angles here are 45 degrees. And then I've basically solved that one, so I'm going to move on to this side length here, and I'm going to make this triangle using the grid lines. And this is a right triangle, so I can again use trig. So here I have a length of 4, and I have a length of 1, 2, 3, 4, 5, so this is 7. And if I do the arctan here, so I have to do tan -1, and I'm going to do 7 over 4. That means that this is my opposite side, this is my adjacent side, and if I put this into my calculator, I get 60.26 degrees. So this angle in here is 60.26 degrees. And what that allows me then to do is I can subtract from 180 degrees to find the angle that I'm looking for. So I'm going to write that in black. This angle in here, and I'm going to call that angle B. Angle B in here, when I subtract, I'm going to end up with 74.24 degrees. Okay, so that's my first angle in the triangle. And I'm going to then go around and finish solving this triangle. So the red triangle, subtracting from 90 degrees, these two angles add up to 90 degrees. This angle in here works out to be 29.74 degrees. Now the last triangle I need to solve for is this one on the outside here. And I'm making my 90-degree angle there. There's my 90 degree, and then I need to solve for this triangle. So I'm just going to count across. It looks like it's going to be 10 by 1. So if I do arctan of opposite is 1, adjacent is 10, so I'm going to find, I'll just draw this a little bit nicer. I'm finding this angle in here using the arctan, and I'm going to end up with 5.71 degrees. So that's 5.71 degrees. This angle in here would be the complement of that, or adds to 90 degrees, so 84.29 degrees is going to be this angle in here. Now, I can then work out the angles inside the triangle now by subtracting from 90 degrees here. So this angle in here is going to be 90, so that's a 90-degree angle in here, minus 29.74 minus 5.71, and I'm going to call this angle A. That angle A is 54.55 degrees. And I can subtract from 180 to get angle C. I can always subtract from 180 here as well. Okay, I can do 180 minus 45 minus 84.29. I can subtract from 180 degrees that add up to the three angles of a triangle. Either way, any way you do it, you're going to end up with 50.71. Now, if you're off by a little bit because of rounding, it just means you rounded it incorrectly, okay, or you forgot to round that last digit. So these are my three angles, and I'll call this angle A, angle B here, and angle C. So we get 54.55. Just list that out. Angle A is equal to 54.55. Angle B is equal to 74.24. and angle C is equal to 50.71 degrees. Okay? So this is a way we can do it. We can make the right triangles on the outside. Now that said, there is a formula that allows us to calculate the angles of a non-right triangle. And these are laws that we call the sine and cosine laws. And we'll look at those in grade 11, but for now, it's easy enough to make our right triangles using the grid on the outside and then use those triangles to help us figure out the angles on the inside.